slight change in the title of the talk. It was says PDF, but we changed to unstructured because there's actually other type of document we want to support for our solution. For example, image can be a version of PDF, or it can be a docx, another. So a late change, but the main format is still the PDF document because that's really the most pervasive file type. So the topic of my talk is unstructured document ingestion accelerator for GenAI application. A little bit about myself. I am a specialist solution architect focused on GenAI and data science and ML. I joined Databricks a year and a half ago. My background is in data science and a machine learning engineer. Apart from AI and big data, I'm a soccer fan. I support Arsenal. Any Arsenal fans? Any Tottenham fan or Man United fans? Chelsea, baby. Okay, Chelsea fans? So we're going to stand up and sing North London Forever. Just kidding. So I'd like to pay tribute to my team, Jazz and Jan. Jazz is the lead SSA in my team, and Jan is the leader of our group. So without them, I won't be here. There are two main goals. In the first half, I would like to share my perspective on the importance and challenges of unstructured data, PDF in particular, and also the life cycle of unstructured data in the world of GenAI, also how that on Databricks. Then I talk about the solution accelerator we're building. The solution is aimed to solve the problem of scaling, in particular for the ingestion and parsing part of that life cycle, and for a batch workflow. It is available now. Why unstructured data? Because it's enormous. This picture is a little old, I think, but analogy of unstructured data as a hidden iceberg is very resonant. I'm pretty sure it's to a lot of you. If you think about it, the knowledge of LLM is essentially trained and learned from open source unstructured data, right? In enterprise, however, this huge potential hasn't been fully discovered, I think. So there's a lot of potential and the discoverability for unstructured data in the enterprise world. I worked with many financial service customers because that's actually where my group is belong to. But I think the type of unstructured data actually is pervasive across multiple industries. So I'm listing so many unstructured data under the financial service with those sub-verticals. In banking, you think of financial statement, balance sheet, receipts, insurance, claims, policy documents, transcript, real estate with loan document, loan application, appraisal. How many of you did a refinance lately? Or I guess interest rate is too high, but last time I did a refinance, it was very painful. So PDF format is still pretty dominant format here, but there's other format. I do want to mention those. Sometimes it's very important as well. How can we extract intelligence from them? So let me show a more concrete example. So imagine you have a stack of receipts and invoices in PDF. Some may be a scanned PDF. To get intelligent of it, maybe the first step, you want to ingest them and also get the metadata and the content parsed in a table form. Here, the content is in markdown text. The reason markdown text is very useful is because LLM really understand markdown as a language. So if your downstream is performing some kind of AI task, markdown format is going to help. Then you could further maybe extract some semi-structured data like JSON to get some key information out. For these invoices, you can get itemized quantity or price and those out. One way for downstream is you can actually transform this into actually a structured data, right? This can be used for AI BI dashboard or for machine learning model. But ultimately, I think the idea is you want to ask a question like this: what is my cash flow outlook? Your assistant or application can intelligently tell you your cash flow situation, the trend is positive, or there's no warning, and it can also give you a visualization, right? That would be great. How do we harness unstructured data? I'm a visual person, so I'm going to show some visuals. The first diagram is a vertical stack. I think those are the key building blocks you will need to harness the power of unstructured data. At the foundation, the data lakehouse architecture is where you can store, right, unstructured and the structured data with this unified governance layer with security. And more importantly, you can discover them. You can find the lineage. Say if you transform unstructured data into structured data, you want to know where those data are coming from. Then on top, you want a very robust data engineering pipelines, capabilities with serverless compute that support batch, real-time, or streaming jobs. It is no doubt, I believe Databricks platform is the ideal platform for these two foundation blocks. Then it is the parsing and the processing technology in the middle blocks, these two orange blocks. We see that typically there can be a two-step process or a single-step process. I think two-step is more mature. So within this two-step process, first is you're doing a parsing. Depends on the complexity of your document. You can use a text parser, or it can be an OCR object detection parser, or it can be a VLM as well. Then on top, you perform LLM inference task, such as key information extraction. That's what KIE stands for. You can do knowledge QA, translation, etc. Then with the latest SOTA, state of the art, that's the acronym below, VLM, prompt engineering, one shot can work as well, but that will require figure out the right prompt and maybe transform or split the document into, convert the PDF into images. So there's a little bit pre-processing and some engineering work as well. After model inference, evaluation is critical. I think Ali, in his keynote, he mentioned about why we think evaluation is important. It's really, you really want to know whether what you built below that is really ready for production, right? So evaluation layer with ML flow evaluation, LLM judge on Databricks, are those capability will be help. And lastly, you have the application on top. So I'm not going to spend time talk about the bottom two layer. I feel most of the audience are familiar with Lakehouse architecture and our platform. So I'm going to double click on the middle two, the orange blocks. We're not short of parsing technologies. As you can see, actually there's many, right? So on the right-hand side, I have a circle of open source ones. Like Tesseract OCR from Google is very popular. And we have PyMu PDF, and Docling is something quite new recently from IBM. They all have their own specialties. On the left-hand side, we have the SaaS version. List a few, like unstructured is actually our Databricks partner. Azure Doc Intelligence, and Llama Index. I think yesterday, Llama Index had a keynote had a talk about their parser. So Databricks also we're introducing a parser called AI Parse. There was another talk on that. I'm gonna mention that towards the end so you guys can check them out. So in my perspective, determine which parse is the best is really not the right question to ask. Because for your situation, for type of use cases, all these trade-offs are very complex. It's not always good and bad. So I was thinking we should consider, in terms of consideration of those trade-offs, I listed a few, but there are actually more. So there's process time. What's the time it takes to process each page? That determines, can you actually finish processing within a certain time frame, right? The accuracy, the cost, the compute, and also the flexibility in downstream AI tasks. So there are a lot of considerations. After parsing, the next step is inference with LLM or the VLM. With Databricks model serving, we have a lot of options. With our model serving, we have foundation models. We also have AI gateway. You can bring external models. Many of these models I listed here are available to use for Databricks users. Cloud Model 4, Sonnet 4, 3.7. They're very good LLM, as well as they also have modality for images. Llama 4, it's also support images. 3.370B is a very general purpose LLM. GPT-4.1 and 4.0 are both multimodal models. And Gemini 2.5 Pro are also multimodal models. All these options are there, but with only the model access doesn't really give your use case complete, because there are other things need to be built around it, right? Like if you want to do information extraction, you want to make sure your output are conform to the schema you define. So it's not always one step. That's why we have Databricks built a set of AI tools. I'm highlighting a couple of really important ones. The first is AI functions. Actually, is a set of UDF functions in SQL that you can talk to LLM directly and allow you to perform a very high efficient batch inference. Then the agent breaks. Maybe if you heard it from the keynote, or task-specific agent for specific business use cases, whether it's information extraction or knowledge assist, which is essentially a RAG agent, and a model specification for fine-tuning. The trade-off is, again, there's a trade-off for time, accuracy, and cost. And as Ali mentioned, we're going to help you to find that trade-off. These sort of a highlight of double-click on those middle two blocks. You had seen the vertical view. Now I'm going to turn 90 degrees. Let me show a horizontal view. So this is an end-to-end view of unstructured data lifecycle on Databricks. Starting from the left, you can have multiple types of unstructured data being ingested in raw format. Had a little model here in that box is potentially you want to have some intelligence ahead of time for you to triage the type of document. If you do have metadata available, you can potentially classify it and determine which task or which string you want to go. Right? That's the beginning. In the bronze layer, you have those raw data ingested in the bronze table. Next block in the silver layer, you have option of using parsers or models to extract the content out of documents. You can use OCR models. I also added AI parse here. There's also a VLM or a text parser here. That's where that's where you get the information or the content from the document out. Branch out in the gold layer. The top half is sort of a batch workload. On Databricks, we have AI functions, as I mentioned previously, that allow you to perform those tasks of information extraction or translation in the batch format. On the very top, this robot sign is the agent bricks. Those agents are also designed to perform those tasks. Typically, after the batch workload, the downstream application can be a dashboard or a Genie, or it can be a table used by other systems or by other internal stakeholders, right? The bottom half is a real-time type of workflow. Typically, you want to start to building a knowledge bot or an agent. So this code layer, typically a chunking strategy is going to apply. Based on what content you extract, you want to see what kind of chunking approach I'm going to be using to ensure that my RAG bot can get in the right information. For example, what's your overlapping, or what's your chunk size? You chunk by page, or chunk by chapter, or chunk by markdown headers, right? Those are the strategy you want to iterate. Typically, the output that agent will go to an app. And on Databricks, we also log what agent produced, so you have a way to monitoring what's happened with agent. Then around that, you do want to build the evaluation, ML flow evaluation block that give you that dev loop, so you can continue to iterate within the goal and evaluation until you reach the quality. Your ML flow evaluation give you the metric to the level that you're satisfied for your application, then you can deploy to end users. Again, at the bottom, these two layers, I kind of mentioned the foundation, like the serverless compute with those tools for the data engineering as well as unit catalog, where we govern all kinds of assets other than just tables, data. We also govern indexes, models, agents, and the tools for the agents. I hope this overall architecture diagram give you guys a good picture of what unstructured data lifecycle is from the ingestion all the way to the application. Despite all these technology, here are the steps. Simplify it into those block diagrams. There are still challenges because devils are in the details. The implementation itself is not straightforward. We see three main challenges. First, actually, it's the trade-off. I think trade-off itself is very hard because you have so many different factors. So it's hard to make that decision. The second challenge is the ingestion. We have a lot of great AI engineers, data scientists who want analyzing unstructured data, but they had a hard time getting those data in, or if they have a huge volume, it's difficult to establish a pattern to have those data in. That's where we hope our Accelerator can help and add value to your workflow. And third is really the evaluation. And I think this is one of the strengths of Databricks because we have a very, I would say, a leading technology in ML ops, traditional classic ML ops. We want to bring that rigors of ML ops with LLM ops to enable this evaluation dev cycle so that you know what you build, whether it's agent or the application for unstructured data is reliable and is production ready. Before I go to the Accelerator, I want to spend a few minutes, maybe talk a little bit about the trade-offs. I think trade-off, I find it's really hard, probably because I'm a person of indecisions. So I like to use a rubric or a decision tree to make that decision. So actually, when I start to prepare for the presentation, I create a decision tree, but it's too big. It doesn't fit into the slides. I kind of iterate like 3 times Finally, with feedback from my boss, and so you cannot do this for presentation. Nobody's gonna read your small font. So I decided to simplify it. So I would say boil down to two key decisions. The first decision is, what is in my document, or what do I want from my document? Starting from the left-hand side, the simpler case, if you only have text, or I only want a text, actually, this is more straightforward. You don't necessarily need any fancy parsers. You can just use naive parse. Or using OCR parser, you can fairly quickly parse the document. For many RAG use case, these can be applicable. Or if your PDF document is quite simple, right? So this can scale really well. So you actually can build a simple pipeline can scale. But if your document has text as well as a table structure, and you do need to maintain that table structure, and for example, if your question in your knowledge bot require you to identify a row, a column in that table, you wanted that table structure to be maintained, or your key value extraction agent be able to get those relative relationships from that table out, you do need to have that. Then you would need, at the minimum, an OCR plus object detection, where the bounding box of the table in the PDF file can be identified, and the table structure is maintained when you parse out. Then the third branch, if you need more than that, you want everything from the document. You want a table, you want a text, you also want an image. Then you need something more powerful. So there are multiple solutions. Databricks AI Parse is one of them. One of the great things about Databricks AI Parse is it not only parsing the components from the document out, but it's also parsing the contextual information, meaning that you can get the information from where each component belongs to what page. So a lot of times these are very useful. For this middle branch and the third branch, that's where our solution Accelerator is currently built for. We hope to help you scale that pipeline. And then lastly, of course, there's always an option on the table that you can using prompt engineering to getting the top models to do prompt engineering VLM on that. But there's a little bit more cost. Getting the document be ready for the VLM is not always straightforward. The second decision is, to me, is what do you want for your application? So there's three common types what we see from the GenAI world. The left-hand side is probably mostly happening last year. It's the RAG, right? The most popular thing in the RAG is knowledge bot, Q&A. But I think starting from the late last year to early this year, we see a lot of people are doing automation. Essentially, agent can orchestrate and automate certain workflows. That bring to like you build a workflow that automate to extract some information, or you want to convert some text, or you want to do some translation, right? Then the third one is, to me, is to getting the unstructured data into structured format. Then you can perform dashboard analysis and so on. I still want to highlight some of the out-of-box tools here for each of those work streams. Knowledge Assist is our RAG agent. Agent framework is for that evaluation. Then the information extraction is our key information extraction agent. Model specialization is for fine-tuning models maybe for converting certain format into another format, or generating certain information from unstructured data. Then lastly, the AI functions for batch inference and the AI BI dashboards. Okay. With that, I'm going to jump into the Accelerator next. So the main goals of our solution is to really enable a scalable, reliable, and high-performing batch workflow. Again, it's a batch workflow. We want to use that workflow to help customer ingest unstructured data and parsing it. Essentially, you can think of it as the first two steps of that lifecycle. Why we focus on that? We think last year a lot of customers discovered how powerful LLM is, how interesting you can quickly build a RAG, get information out. But what they're having trouble is how to bring the key data they want to get information out into the system so they can easily build an agent on top of it. So, and sometimes a lot of those data are in high volume. That's what we think we want to solve that problem or help customers solve that problem. The architecture is straightforward. Again, mapping to the first two steps. Two layer, ingesting unstructured document as a raw binary in bronze layer. Also capture metadata. Then in the server layer, we parse the content out, save as a markdown text. At the downstream, you could choose your path or choose your application, whether it's a RAG for you perform chunking strategy or you want to do information extraction and you do build agent for that. We build a pluggable parser framework. Currently, it supports the open source OCR and object detection model, as well as the Databricks AI parse model. The framework is flexible. We will add more parser in our future roadmap. How do we manage large files? The key design principle is really bucketed documents. So we give user an option to set threshold. One option is set threshold manually based on the file size or based on the page count. As you set up the bundle, you have the choice of choosing your threshold if you want to set that. If you don't set that, by default, you would just do a statistical 3 standard deviation to get outliers as the large files. Then we also have the optional microbatch bin automatically optimized to avoid skew using salted Spark approach. Performance, it's linearly scaled with the cluster resources. Concurrency with microbatch with thread pool. We didn't put any hard number here. The reason one is some of the data we're testing, running our confidential data from the customer. We don't want to disclose that. Then second is the variety of PDFs is so much. I think even though we tested various different kind, we feel like we didn't test all of it. There are so many different kinds. I think the number we're going to say it's going to representing generalized across PDF is probably not the right thing to do. But we're pretty confident we are building a solution that can really help add a lot of value to the customer in just a fairly wide range of PDF format. The error handling is pretty standard. We have retry logic with exponential backoff and fail-safe error logging to another table. Potentially, you can use that for audit trail. Going to do a short demo on that. Learn from the past. I should not do live demo, so I record it. But I couldn't find my mouse. OK. So where's my mouse? Do you guys see my mouse?
Yep. You're in the top right.
Oh. This angle is difficult to see. OK, I see it. Thank you, team. Data as a bundle in the command line. you can set, when you launch the initialization, you can give a project name. After that, you choose cloud provider. Currently, we just support AWS and Azure. You can define your threshold. I define 10 page, more than 10 page, then it's a large file for this particular demo. It takes a little while to have this Python whale-based bundle file being generated. After generated, you have certain configuration file. You can config the workflow. But here I'm showing an example where I define the workflow configuration as variables: catalog, schema, volume, the number of workers you want to use, what kind of parser you want to use. After that, you can deploy it as a workflow on Databricks. Take a little bit to upload it. Now deployed, you can launch the workflow on the command line. That's one way to do it. I think next going to show the workflow. So this is the toy example, but we tested hundreds, thousands of files. You get, for dev or product, you have an async workflow for async large file. Then you have a regular workflow for the general batch files. This is based on structured streaming. So you have bronze job layer. So in this case, the majority of the time is actually bring up the node, the parsing, because I have very little file, so the parsing is really quick. Then this is showing the large file has its own separate node and has its own separate string. For example, if you have like 5,000 jobs, 10 are really large file, they're going to run on their own, but they're not going to block the rest. This is showing the raw file being ingested. You get the raw binary as well as the size and the timestamp and the page count. The page count is blocked. I think it's going to show to the end. There's a page count. There's one large file has 17 pages. So that would be because I set the threshold to 10, so that's the large async job. Then after the server layer, the markdown content is being extracted. The table format is being maintained. For example, in this case, where you have invoices, you want to itemize. Each itemize to be listed within a table, so they can be inferred by the LLM. I think that's it for the demo. Thank you all for guiding my mouse. Probably need help again. Oh, I think I can do it this time. Oh, I'm going to jump to the next one. So it's coming. So we are continue working on this. We're just getting started. So we want to add memory management. We also want to further enhance the processing performance, especially for those large files. Currently, the large file just submitted into async async jobs and have its own dedicated compute. You can set that compute to be larger than the other ones, but ideally we want to optimize that large job, maybe using MapReduce approach to maybe split the document and bring them together. So this is something we're currently working on. We want to integrate new parser and VLM options. And lastly, it's our innovative project. We're trying to see whether we want to introduce a declarative document parsing, which is an idea. It's very interesting, is that instead of say, I want to parse everything from your document, if I already know something, let's say you have 10K from a company report, I only want the revenue, or I only want a certain part of that document. Can you using declarative language to identify where I want to parse? So a lot of things coming, but we're working on it. And call to action, try our repo link I'm sharing here, and reach out to us. This is my email. I want to shout out to AI function, which I think is a great feature for batch inference. Also this talk. This is a talk I mentioned about the intelligent document parsing the AI parse team are doing. So I think it's maybe ahead of this one, so you might have to check out the recording. Perfect. I have 5 minutes for questions.